In the seventh episode of the series on probability and statistics, we will be delving into the fascinating world of distributions. You see, probability is this fantastic concept that ranges from 0 to 1, essentially telling us whether an event is likely to happen or not. Now, distributions come into play by mapping these probabilities to random variables. These random variables are then graphed in a two-dimensional space, and this particular plot is known as the Gaussian distribution. Of course, there are many other distributions out there like the binomial distribution, Poisson distribution, log normal distribution, etc., each with its unique applications. But at the heart of it, when we talk about distributions, we are essentially dealing with probabilities. Now, let's zoom in a bit on the Gaussian distribution, also known as the normal distribution, a cornerstone in statistics. Picture it as this elegant bell shaped curve. The mean, median, and mode for this curve are all the same, right at the center. This means that data is symmetrically spread around the central point, making the likelihood of observing values above and below the mean equal. Speaking of mean and variance in the Gaussian distribution, the mean acts as the distribution's center while the variance dictates how spread out the data points are. A smaller variance gives you a narrower peak, while a larger one results in a broader one. Essentially, a larger variance means more data spread. Before we move on, let's clarify what variance is. It's simply a measure of how data is spread out. Variance is the square root of the standard deviation, and standard deviation is the sum of the squares of errors divided by the total number of observations. Don't worry, we will dive deeper into these aspects of descriptive statistics in future episodes. Now, the 68 95 99.7 rule in Gaussian distribution is a neat trick to remember. It tells us that roughly 68% of the data falls within one standard deviation from the mean. That is mean plus and minus one standard deviation. For two standard deviation, it's about 95%. And for three standard deviations, it's about a whooping 99.7%. That means only a tiny 0.3% of the data falls beyond this range. Gaussian distribution is everywhere in the real world, from height and weight distributions to errors in measurements, among many other things. Understanding it is key because it helps us make statistical inferences, conduct hypothesis testing, and model various aspects of our world. It's a foundational concept for many statistical methods and machine learning. So, in the next episode of the series, I will be diving into a practical problem related to Gaussian distribution. Stay tuned for exciting content ahead.